Namaskar. Dear students, welcome. Today I am going to solve these 4 problems. We are discussing about Bernoulli's differential equations. We are solving problems on linear differential equations and the Bernoulli's differential equations, and some equations which can be converted to the linear differential equation of first order and first degree. Today we have we shall try to solve these 4 problems. These problems are either of linear form or Bernoulli's form, or it can be converted to the linear form. Let us try to solve the equation number 1. Differential equation number 1. Number 1. The given differential equation is sin y into dy by dx equal to cos y into 1 minus x cos y. 1 minus x cos y. This. You see, this differential equation can be written as, this means tan y into dy by dx, this is equal to 1 minus x cos y. You may write like this. Tan y dy by dx, this is dy by dx, tan y dy by dx equal to 1 minus x cos y. Or you may write it like this. This differential equation, thus this cos y, take this cos y here. Sin y by cos y means tan y, or dividing the equation by cos y. Tan y into sec y multiplied by sec y dy by dx, this is equal to sec y minus x, because cos y into sec y equal to 1, cos y into sec y equal to 1. We can write like this. Now put sec y equal to v, then you will get tan y into sec y dy by dx. This differential equation can be written as, again, tan y into sec y dy by dx minus sec y equal to minus x, minus sec y equal to minus x. Now put sec y equal to v. This is number 1. Put sec y equal to v. Sec y equal to v. This means d dx of sec y equal to dv by dx. This means sec y tan y dy by dx equal to dv by dx. This is equal to dv by dx. You may write like this. Now, you see, suppose the differential equation 1 can be written as, therefore 1 becomes, therefore 1 implies, you may write 1 implies tan y sec y dy by dx means dv by dx. You write dv by dx minus, for sec y write v equal to minus x. This is equal to minus x. Okay. This is a linear differential equation. Now 2 is linear, which is linear in V. Linear with V as dependent variable and x as the independent variable, which is linear in V. Integrating factor. Let me remove this one. Minus x. Yes. Therefore, linear in V. Integrating factor equal to e to the power integral. P means minus 1 into dx. This is equal to e to the power minus x. Integrating factor is e to the power minus x. Now 2, multiply 2 by the integrating factor. Then you will get e to the power minus x dv by dx minus e to the power minus x into v equal to minus x e to the power minus x. Minus x e to the power minus x. E to the power minus x. This means d dx of e to the power minus x into v equal to minus x e to the power minus x. Integrating we get. Integrating we get. Integrating we get. You will get e to the power minus x v equal to minus integral x to the x e to the power minus x dx plus c. Dx plus c. E to the power minus x dx plus c. You will get this one. Integrating you will get this. Now, now you see. This means e to the power minus x. What is it? V means sec y equal to minus. This is a product function, first function x, take first function x into integration of the second function minus e to the power minus x minus integral differentiation of the first function and integral of the second function. What is the integral of the second function? Minus e to the power minus x dx plus c minus, which is equal to this is equal to minus x e to the power minus x plus integral e to the power minus x dx plus c. You will get this one. Or this is equal to minus x e to the power minus x minus e to the power minus x plus c. You will get this one. Now, this will be plus, this is equal to x e to the power minus x plus e to the power minus x plus c, and in left hand side it was e to the power minus x sec y, or sec y equal to, you may write x plus 1 plus c e to the power x, which is the required solution. This is the required solution. Answer is this. Which is the required solution? This is the required solution. Answer is this. This is the answer. Now we have solved the equation number one. We have solved number 1. Let us come to solve the number 2. Number 2. Very easy, and for revision I am solving this. We have solved so many problems about the linear differential equations and Bernoulli's differential equations. Now, number 2. What is this? dy by dx plus y cot x. dy by dx plus y cot x. This is equal to y square sin square x cos square x. This is number 1. Sin square x cos square x. Sin square x cos square x. Now, what is this? This differential equation is directly Bernoulli's differential equation. It is of the form dy by dx plus py P means cot x, y equal to q, y to the power n. Q means sin square x, cos square x. Direct Bernoulli's equation. To solve this Bernoulli's equation, just divide the differential equation by y square. Dividing 1 by y square we get. Dividing 1 by y square we get. Dividing 1 by y square we get y to the power minus 2 dy by dx plus it will be 1 by y by y square means 1 by y means y to the power minus 1 cot x equal to sin square x cos square x. Sin square x cos square x. Now suppose this is number 2. What is your next step? Put y to the power minus 1 equal to 2. Put y to the power minus 1 equal to v. Put y to the power minus 1 equal to v. Now differentiate this with respect to x, both sides. Differentiating both sides with respect to x, you will get this one. Then you will get this means minus y to the power minus 2 dy by dx equal to dv by dx. You will get this one. Or y to the power minus 2 dy by dx equal to minus dv by dx. Minus dv by dx. Therefore 2 becomes. Therefore 2 will become. Therefore 2 implies. Therefore 2 implies. For this you may write minus dv by dx. Minus dv by dx. Plus cot x into v. Cot x into v. Y to the power minus 1 means v. This is equal to sin square x cos square x. Sin square x cos square x. Or this means dv by dx minus cot x into v equal to minus sin square x cos square x. Sin square x cos square x. Suppose this is number 3. This is number 3. Now just carefully see the equation number 3. It is obviously a linear differential equation with v as the dependent variable and x as the independent variable. It is a linear differential equation with v as the dependent variable and x as the independent variable. Which is linear in v? Which is linear in v? Which is linear in v? Integrating factor will be equal to e to the power integral minus cot x. E to the power integral minus cot x dx. This is equal to e to the power minus, it is log of sin x. This is equal to e to the power log of 1 by sin x, which is equal to 1 by sin x, or you may write it as cosec x. It as cosec x. Multiply 3 by cosec x. Multiply 3 by cosec x. We get. Multiply 3 by cosec x. We get. Multiplying 3 by cosec x. We get. By cosec x. We get cosec x into dv by dx minus cosec x cot x into v, cosec x cot x into v. This is equal to multiply by cosec x, then you will get minus sin square x cos square x into cosec x. Sin square x cos square x into cosec x. You will get this one. Multiply equation number 3 by this. Multiplying this, we will get this one. Get this one. Now, this means d dx of, can I write it as cosec x into y? No, not cosec x into v. Cosec x into v. Into v. First function cosec x, differentiation of the second function dv by dx plus v. Differentiation of cosec x is minus cosec x into cot x. This is equal to minus sin x into cos square x. Minus sin x into cos square x. Because sin x into cosec x equal to 1. Sin square x into cosec square x, cosec x will be equal to sin x. It will be this. Integrating we get cosec x into v. This is equal to minus, this is equal to, you may write integration minus sin x cos square x dx plus c. Integrating, you will get this one. What is v? V is equal to 1 by y, or y to the power minus 1. This is equal to, if you put cos x equal to z, differentiate it, minus sin x dx equal to dz. Cos x is equal to z, minus sin x dx is equal to dz. It will be z square dz, means z cube by 3, means cos cube x by 3 is equal to cos cube x divided by 3. Cos cube x divided by 3 plus c. Cos cube x divided by 3 plus c. What is v? V means 1 by y. This means cosec x into 1 by y equal to cos cube x divided by 3 plus c. Cos cube x divided by 3 plus c. Or you see, this means for c you may write c1 by 3. Suppose c1 by 3. 1 by sin x, 1 by y equal to cos cube x by 3 plus, suppose this is c1 by 3, where c equal to c1 by 3. Another constant, suppose like this. Now, this can be written as 3 equal to y into sin x cos cube x plus c1. This is the answer. Or you may write here also answer. Cosec x into 1 by y equal to cos cube x by 3 plus c1 plus c. This is the answer. You may write this is the answer, or y equal to 3 equal to y sin x into cos cube x plus 3 c1. This one is the answer. Therefore, we have solved this one also. Question number 2. We have solved question number 2. Now, let us come to solve the question number 3. Let us see. Perhaps you have noted down. Question number 3. What is 3? Very simple. dy by dx plus y by x equal to x square. Given that y is equal to 1 when x is equal to 1. That is a particular solution. After solving the differential equation, In the solution, we will get one arbitrary constant, and with the given condition y is equal to 1 when x is equal to 1, we shall find the arbitrary constant. For that the particular value, what will be the solution? This is the case. Now first let us solve the differential equation. This one is linear. It is linear in y, which is linear in y. One is linear in y, linear in y, linear in y, with y as dependent variable, x as independent variable. Integrating factor equal to, what is integrating factor? E to the power integral 1 by x dx. Integrating factor is equal to this. This is equal to e to the power log x. This is equal to x. Multiply 1 by x. 1 into x. 1 into x implies x dy by dx plus y. This is equal to x cube. X cube. Or d dx of xy. This is equal to x cube. Integrating we get. Integrating we get xy equal to integration x cube dx plus c. X cube dx. This is the integration. Now this means xy equal to x to the power 4 by 4 plus c. Suppose this is number 2. If suppose this condition, if this condition is not given, then this is the answer. Now given that x is equal to 1, given that y is equal to 1 when x is equal to 1, when x is equal to 1, therefore from 2 we will get, from 2 implies 1 into 1 equal to 1 to the power 4 by 4 plus c. This means 1 equal to 1 by 4 plus c, or c is equal to 3 by 4. C is equal to 3 by 4. You will get c is equal to 3 by 4. Therefore, putting c is equal to 3 by 4 into we get xy equal to x to the power 4 by 4 plus 3 by 4. This means 4xy equal to x to the power 4 plus 3. X to the power 4 plus 3. This one. This is the answer. 4xy equal to x to the power 4 plus 3. This is. We have solved number. It is very simple. Number. Let us try to solve the equation number 4. Number 4. So that the equation of the curve whose slope at any point is equal to y plus y6. Slope. The slope of the curve. This is dy by dx. Dy by dx equal to y by y6. Here dy by dx, slope of the curve equal to y plus y6. Y plus y6. Now, you see, dy by dx, slope of the curve equal to y plus y6. Therefore, dy by dx is equal to this. You may write here also, or you may write like that. Slope of the curve is at any point is y plus twice x. Therefore, dy by dx is equal to y plus twice x. Now, this means dy by dx minus y equal to twice x. This is linear. Which is linear? Which is linear in y? Which is linear in y? Linear in y. Integrating factor equal to e to the power integral p dx equal to e to the power minus x. E to the power minus x. Therefore, 1 implies e to the power minus x dy by dx minus y e to the power minus x twice x e to the power minus x multiply by the integrating factor. Obviously, if you multiply the equation by the integrating factor, then left hand side will become d dx of integrating factor into the dependent variable. Obviously, it will be d dx of integrating factor is e to the power minus x this, or you may check here also first function e to the power minus x dy by dx plus y differentiation of e to the power minus x is minus e to the power minus x. This one. This is equal to twice x e to the power minus x. Twice x e to the power minus x. Integrating we get. Now integrating we get. Integrating we get. Integrating we get e to the power minus x. Why? This is equal to just 2x e to the power minus x dx plus c, where c is the constant of integration. You may write here where c is the constant of integration. Now, this is equal to 2 first function x integration of the second function minus e to the power minus x minus differentiation of the first function minus integration of the second function whole integral this equal plus c, integral plus c. This is equal to 2 minus x e to the power minus x plus integral e to the power minus x dx plus c. This is equal to 2 minus x e to the power minus x minus e to the power minus x plus c. You may write like this. And what is this? E to the power minus x into y. E to the power minus x into y is equal to this. Or e to the power minus x into y. Now, this means e to the power minus x into y minus 2 e to the power minus x plus 1 into e to the power minus x plus c plus c. Or you may write y equal to minus 2 x plus 1 plus c e to the power x. Suppose this is number 2. Suppose this is number 2. Now, just see the question. So that the equation of the curve whose slope at any point is equal to this, also, and which passes through the origin. Passes through the origin. According to the question, equation number 2, this curve passes through the origin 0, 0. According to the question, 2, the curve, equation of the 2 passes through the origin 0, 0. Passes through the origin. Through the origin. This passes through the origin 0, 0. 0, 0. Passes through the origin 0, 0. Therefore, therefore, from 2 you will get 0 equal to minus 2, 0 plus 1 plus c e to the power 0. This means 0 is equal to minus 2 plus c. This means c is equal to 2. C is equal to 2. Therefore, from 2 you will get. Therefore, from 2 you will get. Therefore, 2 implies y is equal to minus 2 x plus 1 plus 2 e to the power x. You will get this one, 2 e to the power x. This means y is equal to 2 into e to the power x minus 1, you may write like this, which is the equation of the curve. This is the equation of the curve. This is the equation of the curve. Therefore, we have solved this one. Therefore, we have solved this one. This is the equation of the y is equal to twice e to the power x. Dear students, we have solved 4 problems today. In the next class, we shall start the exact differential equations. Exact differential equations. After completing this, then we shall try to solve problems from your textbook, rows and simply from your textbook, and we shall solve all exercise, all problems in all exercises. Today I want to stop here. Thanks for attending the class. Thank you very much. Thank you. Namaskar. Dhanyavad.